Hi, my name is Takafumi Morita. I'm a graduate student at the University of Tokyo X Labo. In this video, I'm very excited to talk about our research paper named HydroMod, Constructive Modules for Prototyping Hydraulic Physical Interfaces. Let's take a quick look at HydroMod with a preview video in the first 30 seconds. We propose HydroMod, novel constructive modules that can easily generate liquid flow and programmatically control liquid flow. HydroMod consists of palm-sized small modules. With HydroMod, users can easily program and prototype the liquid behaviors. Nowadays, toolkits have been developed for easy prototyping of electronic systems. These toolkits not only allow beginners and hobbyists to handle electronic equipment without specialized knowledge, but also researchers and engineers to prototype more quickly. Previously, HCI researchers have also explored a variety of approaches such as intuitive modules, wearables, or soft materials. In the field of HCI, there has been a significant amount of research on programmed matter, where the material itself has interactivity. Physical interfaces with gases and liquids are attracting attention for various applications such as dynamic deformation, dynamic stiffness, fluid sensing, or actuating. Furthermore, liquid has many characteristics that cannot be expressed by gases, such as heating and cooling, kinetic movement, color expression, or chemical reactions. As you can see, there are various pneumatic and hydraulic interfaces with their own characteristics. However, the development of platforms for prototyping with gases and liquids is a developing area because the prototyping must be built from scratch and requires specialized knowledge. Several toolkits for handling gases have been released in recent years. However, there are still very few toolkits for handling liquids. There are three major challenges in handling liquids. First, many large devices such as pumps, tanks, or valves are required to generate liquid flow. Therefore, the systems are complex and can't be used outside. Second, it is difficult to reconfigure the flow path design. Once the flow path is specified and designed, it takes a lot of time to reconfigure it again because conventional hydraulic systems are not designed to be disassembled frequently. Third, the hydraulic system is vulnerable. If any part of the system is defective, the working liquid will leak, and the system won't function properly. To overcome the challenges, we propose novel constructive modules for hydraulic physical interfaces. We developed HydroMod with the aim of lowering the barrier to entry for prototyping with liquids. HydroMod supports 3 types of main modules and 4 types of additional parts. The main module consists of actuated module, pump module, and wire module. The additional parts consist of a battery, connector, small tank, and tube. Each module has a built-in magnet as a connection. It is easy to create flow paths and electronic circuits by simply connecting their modules with the magnets. HydroMod requires only 5 steps to construct and operate the hydraulic system by simply connecting the modules. First, the pump module is placed at an arbitrary position. Subsequently, the actuated module is connected to the pump module. Next, the additional parts such as connectors, tanks, or tubes are attached to create paths as needed. And then, the user injects the electronic liquid in the created hydraulic system. Finally, UI such as smartphone is used to remotely control the created system. As you can see, liquid flow is controlled easily. Furthermore, the process of connecting the module from A to C can be reconfigured as many times as needed. This eliminates the difficulty of reconfiguring the hydraulic system, which was a challenge in previous hydraulic systems. HydroMod uses the VHG phenomena, the pump function, to generate the liquid flow. As you can see, this animation shows the operation mechanisms of cone-shaped electrodes used in an EHD pump. The EHD phenomenon occurs when a high voltage is applied to a dielectric liquid. Hydraulic system using HydroMod can dynamically and tangibly control liquid flow, which wasn't possible with previous hydraulic systems. This control method can be controlled just by attaching the actuated module So there's no need to use additional equipment such as mechanical valves. HydroMod can tangibly affect changes in behavior such as pressure and flow rate simply by connecting the pump modules. Connecting the pump module in series increases the pressure. As you can see, the pressure values increase according to the number of pump modules. Connecting the pump modules in parallel increases the flow rate. In this way, depending on the number of pump modules and how they are connected, it is possible to design a tangible hydraulic system. We present 3 applications using HydroMod. This shows an actuated seesaw grid by combining HydroMod. By moving the liquid inside the seesaw object, the position of the center of gravity is changed, and it functions as an actuator with kinetic movement. This application is based on weight manipulation, which are characteristic of liquids. This shows a silent pin-based color display grid by combining HydroMod. This pin-based display can silently show a synchronized liquid representation for each module, such as the wave representation. This application is based on color expression, which are characteristic of liquids. This shows a wearable mobile hydraulic interface grid by combining HydroMod. This is a wearable interface that can control cooling by liquid and can be used for mobile or outdoor applications. This application is based on heating and cooling, which are characteristic of liquid. In conclusion, in this paper, we aim to lower the barrier to entry for prototyping with liquids. Therefore, we propose HydroMod. HydroMod can easily generate liquid flow and programmatically control liquid flow. We also evaluate the performance of HydroMod as a hydraulic system and show the possible application scenarios. So in this paper, we have 4 main contributions. First, we propose novel constructive modules that allow easy and reconfigurable hydraulic prototyping. And second, we realized liquid behavior such as their direction, pressure, and flow rate by really reconfiguring modules. And third, good control of each hydraulic system was made possible by synchronizing multiple modules wirelessly. And fourth, small standalone driven modules made it possible to use hydraulic system for mobile or outdoor applications. As you all know, Arduino democratized electronic prototyping in the past. On the other hand, several toolkits for handling gases have been released in recent years. Therefore, pneumatic prototyping is also becoming available to anyone without specialized knowledge. Our motivation is now to democratize hydraulic prototyping in a similar way. In order to achieve this, the next step is to create a developmental environment and a community for HydroMod. In the future, we hope that further researches and ideas will be generated so that hydraulic prototyping can be done as easily by anyone as electronic prototyping is already done today. In the near future, in the wake of this paper, we hope that hydraulic interfaces will become part of our everyday lives. Lastly, I would like to thank my co-authors and collaborators. I'm happy to take any questions. Thank you.